what is the first step in your design? What do you think? We have 3 steps to design before starting to construct your building. We have architectural design, we have structural design, we have structural drawing. Can you watch this one?
Mm-hmm.
Is it my responsibility as engineer to draw this sheet or this plan?
No.
No, I'm not architectural engineer. It's a different program, different department, which called architectural department. We are construction. We can design, structural design. We can construct inside, but we cannot start, where is my bedroom, where is my bathroom, where is the kitchen, where is the living room, where is the stairs, all of this stuff. We didn't learn anything about this stuff. So we will assume we have a ready architectural design for you. That's fine? So the first step, architectural plan, is a design and planning for your building. And it can contain architectural drawing, specifications of design, time planning, maybe related to management of the building process, and the other documentation, contract between the owner and the contractor. All of this stuff can be done during this process. Then we need to structure design this building. We are structural engineers. We learned concrete design, we learned steel design, we learned structural analysis. So we can handle this one. Structural design means stability of your structure. Your structure must be stable. Strength and rigidity of your structure. Basic objective in structural analysis and design is to produce a structure capable of resisting all applied loads without failure during its intended life. We need your structure to be safe and economic and stable during the intended life. Then, after you design, we need to convert or to translate your design calculations to drawing. Hey, you will say, hey, area steel equal 4.15 inches square, 0.85 FC prime, A, B equal area steel F yield. Your design nominal moment equal blah, blah, blah. All of these calculations, I cannot go to the site and say for the worker, hey, can you read these calculations? He will say, I cannot understand anything from your calculation. But if you draw this rectangle and put this shape and tell me 3 number 4 and tell me we have dimension like this or like this, the worker can understand. So I need to convert, translate my design calculations to drawing to be understood. Any question? So first step, also during your capstone project, you are looking for something like this. I'm not sure Dr. O will provide you for all of this stuff, or you need to search for architectural design. We need to start our structural design. We have a lot of work. For your floor, we have a slab, we have beams, we have columns. We need to design slabs. What is the thickness of your slab? How much steel reinforcement in both directions? For beams, your beam, how much longitudinal reinforcement? How much stirrups you need? For columns, what is the cross-section area of your column? What is the area steel in your column? Design of stairs. Any building has stairs. That's right. What is your stair here? This one?
The stairs and
Stairs.
elevator.
This one is 3 flight stairs. 3 flights means you need to walk, then another walk, then another walk. So it's called 3 flights. Maybe it's 2 flights sometimes. Anyway. So we need to design our stairs. Your stairs may be 2 flight, 3 flight, or helical. Sometimes. Design of foundation. This building, this plan for repeated flow. This structure is supporting on ground. What is the type of your foundation here? What is the design of your foundation embedded in your soil? So all of these questions is related to our work as a structural designer. So for this project, we will design slabs, beams, columns, we'll design foundations. Maybe if you would like, we can talk about stairs. Let's start with the first one, slabs. Actually, we have many different types of slab. But the most common type of slabs, these two types. What is the difference between the two? This one called solid slab. This one called flat slab. What is the main difference between both of them? Remember, this area is the same like this area. But I decided to use here solid slab, but here flat slab. It's up to you. But what is the difference between this one and this one? Solid slab means your slab itself is supported by beams from each side of your panel, and each beam is supported by columns. So the structural system for solid slab, your slab supported by beam and your beam supported by column. So each panel must have 4 beams at each edge, and we have column supported your beam. The second type of slab, which is called flat slab. No, we don't have beam. Your slab supported directly on your column. So the structural system for this type of slab, your slab directly supported on column without any intermediate or edge beams. What do you think? Which one is stronger from structural design?
Solid.
Which one is stronger?
Solid.
Sure, this one. Because your slab is 4 inch, only 4 inch, maybe 5 inch. But your depth of your beam, 30 inch. So it's stronger. But why sometimes we need to use this one?
Slider.
For what?
Slider.
Maybe
Quicker.
quicker. Yeah, economic maybe. One more thing. During some type of building, I don't like to see these beams coming down from the slab. I don't like this shape. I would like to see that the slab is only one flat surface. So maybe I don't like to see any dropped beams from the slab. Maybe I have ducts for air condition, for anything else. So if you have dropped beam and you have ducts, so we have something wrong will happen. Or you can put your ducts behind your beam, so we need very high, or your height of one floor will be higher than required. Anyway, so, but stronger, this one. Maybe from architectural design, we can prefer this one. But the main difference between this one and this one slab supported by beam, beam supported by column. Here your slab is supported directly by column. We have something also, we have issue with this one. What do you think?
They require more concrete on the, on the top of the column. That way they
Wider
doesn't-
columns?
Yeah,
Why?
because it's gonna break.
Why?
Um,
Your slab very thin related to the beam. Beam is 30 depth, 30 inch, but your slab is 5 or 4 inch. What do you think if you have very thin plate rested on a column like this? Bunch. You can expect bunch like this. Yeah, this happened many times. Failure, complete failure in your building due to this failure for flat slab. You have a very huge reaction from your column, and your column is very thin. Your dimension maybe 18 inch or 20 inch, very thin, and your slab very thin also, 4 inch only, so you can expect something called bunching. But this will not happen. Anyway, will not happen if you have beams, because the depth of your beam very large. Okay, let's see. According to ACI, thickness of your slab, you can get it from these values. So if your beam is simply supported between this, if your slab supported between two beams only, so you can get your thickness by L span divided by 20. One end continuous from one end, your span divided by 24. If you have two spans, your area is rectangular area, so you have two different spans, you can use the biggest one. Both ends are continuous or cantilever, you can figure out your thickness from this table for solid slab. Minimum steel reinforcement, you can get your minimum steel reinforcement based on what is the type of bars and what is the F yield of steel. I can show you this video to explain what is the meaning of solid slab.
Grammarly does more than catch errors. With Grammarly, you can find really good.
I'm sorry.
A beach house, a cabin, a great place.
Oh. Are you sure? We have a column. Between each column, we have a beam. Your beam, mainly, we have longitudinal bars for moment. We have stirrups for shear. Sometimes we can make your longitudinal bars to be bent like this to support shear also. So this shape is supporting shear at this location. Do you remember last time? We can expect shear failure with inclined angle, 45 degree here. So you are doing your steel reinforcement perpendicular to expected crack to close this crack. Anyway, keep going. 4 beams around your slab over these 4 columns. What is the difference between this beam and this beam and these 2 beams?
Beams and girders.
Yeah, these beams supported directly on your column, but this beam is supported between 2 another beams. So we have beam here, we have another beam here, and this longitudinal beam is supported by the 2 beams. If you would like to draw or to do your structure analysis, this beam will have one concentrated load here coming from the reaction of this beam. Four more. Just marks. So we understand what is the steel for our beam. We have bottom reinforcement, we have top reinforcement, we have stirrups. That's right?
Right.
Mainly the bottom reinforcement are the main reinforcement, the top just for to hang your stirrups. But for slab, we have mesh of steel reinforcement.